Chapter 1, Section 1. Chemistry is a physical science. This chapter defines the field of chemistry and distinguishes between different branches of chemistry. There are 3 learning targets for Chapter 1, Section 1. You should be able to define chemistry. You should be able to list examples of the branches of chemistry. And you should be able to compare and contrast basic research, applied research, and technological development. The natural sciences were once divided into 2 broad categories, the biological sciences and the physical sciences. Living things are the main focus of the biological sciences, and the physical sciences focus mainly on non-living things. However, because we now know that both living and non-living matter have a chemical structure, chemistry is central to all of the sciences, and there is no longer distinct divisions between biological and physical science. Chemistry is the study of the composition, structure, and properties of matter and the changes it undergoes. Chemistry deals with questions such as, what is the material made of? What is its makeup and internal arrangement? How does it behave and change when heated, cooled, or mixed with other materials, and why does this behavior occur? Chemists answer these kinds of questions in their daily work. Instruments are routinely used in chemistry to extend our ability to observe and make measurements. Instruments make it possible, for example, to look at microstructures, things too tiny to be seen with the unaided eye. The scanning electron microscope reveals tiny structures by beaming particles called electrons at materials. When the electrons hit material, they scatter and produce a pattern that shows the material's microstructure. Invisible rays called X-rays can also be used to take a look at microstructures. The patterns that appear, called X-ray diffraction patterns, can be analyzed to reveal the arrangement of atoms, molecules, and other particles that make up the material. By learning about microstructures, chemists can explain the behavior of macrostructures, which are the visible things all around you. Chemistry includes many different branches of study and research. The following are 6 main areas or branches of study. But like the biological and physical sciences, these branches often overlap. 1. Organic chemistry, the study of most carbon-containing compounds. 2. Inorganic chemistry, the study of all substances not classified as organic, mainly those compounds that do not contain carbon. 3. Physical chemistry, the study of the properties, changes, and relationships between energy and matter. 4. Analytical chemistry, the identification of the components and composition of materials. 5. Biochemistry, the study of substances and processes occurring in living things. 6. Theoretical chemistry, the use of mathematics and computers to design and predict the properties of new compounds. In all areas of chemistry, scientists work with chemicals. A chemical is any substance that has a definite composition. For example, consider the material called sucrose or cane sugar. It has a definite composition in terms of the atoms that compose it. It is produced by certain plants, which use carbon dioxide and water in the chemical process of photosynthesis. Sucrose is a chemical. Carbon dioxide, water, and countless other substances are chemicals as well. Knowing the properties of chemicals allows chemists to find suitable uses for them. For example, researchers have synthesized new substances such as artificial sweeteners and synthetic fibers. The reactions used to make these chemicals are carried out on a large scale to make new products such as sweeteners and fabrics available for consumers. Basic research. Basic research is carried out for the sake of increasing knowledge, such as how and why a specific reaction occurs and what the properties of a substance are. Chance discoveries can be the result of basic research. The properties of Teflon, for example, were first discovered by accident. A researcher named Roy Plunkett was puzzled by the fact that a gas cylinder used for an experiment appeared to be empty, even though the measured mass of the cylinder clearly indicated that there was something inside. Plunkett cut the cylinder open and found a solid, white material. Through basic research, Plunkett's research team determined the non-stick properties, chemical structure, and chemical composition of the new material. Applied research. Applied research is generally carried out to solve a problem. For example, when refrigerants escape into the upper atmosphere, they damage the ozone layer, which helps block harmful ultraviolet rays from reaching the surface of Earth. In response to concerns that this could pose a potential health problem, chemists have developed new compounds to replace refrigerants. In applied research, the researchers are driven not by a simple curiosity or a desire to know, but by a desire to solve a specific problem. Technological development. Technological development typically involves the production and use of products that improve our quality of life. Examples include computers, catalytic converters for cars, and biodegradable materials. Technological applications often lag far behind the basic discoveries that are eventually used in the technologies. For example, non-stick cookware, a technological application, was developed well after the accidental discovery of Teflon. When it was later discovered that the Teflon coating on cookware often peeled off, a new problem had been solved. Using applied research, scientists were then able to improve the bond between the Teflon and the metal surface of the cookware so that it did not peel off. Basic research, applied research, and technological development often overlap. Discoveries made in basic research may trigger ideas for applications that can result in new technologies. For example, knowledge of crystals and the behavior of light was gained from basic research, and this knowledge was used to develop lasers. It was then discovered that pulses of light from lasers can be sent through optical fibers. Today, information such as telephone messages and cable television signals can now be carried quickly over long distances using fiber optics. There are 3 learning targets for Chapter 1, Section 1. You should be able to define chemistry. You should be able to list examples of the branches of chemistry. And you should be able to compare and contrast basic research, applied research, and technological development.